All right, let's take a look at some of these lesson 12 homework questions. And so I pulled mine up, but I do have some different numbers than what you gave me. I'm going to try and show you with the numbers that you gave me, but the idea is basically the same. And so the first one was, we have two six-sided dice that we're rolling, and we're trying to figure out these probabilities. The first one being, what's the probability that you will roll doubles? And you had the right idea there, so I don't know what happened with that. It should be, we have 36 possibilities with these two dice, and so we are dividing out of 36, and there are 6 ways that we can get doubles, right? We can have double 1s or 2s or 3s or 4s, 5s or 6, and so 6 out of 36 is what we'll get. So like I said, you had that, and so I don't know what was going wrong with that one. Should have been coming out right. And it did say it wanted this as a number between 0 and 1, a decimal, and so dividing that out gives us kind of this long repeating decimal, and I think it wanted 2 decimal places, and so it did mark this correct for me if I put it in as 0.17 on this one as that probability. And so I don't know if there was just some rounding or something going on that was causing issues there. The next one you said was the probability that you will roll a sum of 6. Mine says 4, but we'll work with 6. And so still out of 36 possibilities, right? And so that bottom number is still going to be 36, but we need to figure out a new top number, so we need to look at the ways that we can roll 6. And this is a little bit tricky because we have to look at we have more cases than you expect, and so what we can get is, if I roll a 1 on my first die and then a 5 on my second die, that will total 6, right? But then I have a separate case, I have to count this as being different if I roll a 5 on the first die and a 1 on the second die, right? And so these look like they're the same thing, but they're not really. I have to count these as 2 separate outcomes, because here's one die, and so here's our first die right there, and here's our second one over here. And so I have to treat these differently, because this case I had a 1 on this die, and this one I have a 5, and that's different, if that kind of makes sense, even though these look like the same thing. So 2 cases there, and then I could also roll a 2 and a 4, right? Or it could be a 4 and then a 2. And then our last one that we have is if we roll a 3 on both die. And I only have to count that one once, because if I swap places, it's still just 3 and 3 on that. And so I end up having 5 cases where I could roll a 6 on this, and so it should end up being 5 out of 36, and so as a decimal that would be 0.14, rounded to 2 decimal places, looks like. Or if we want to see it on mine says if we roll a sum of 4, my possibilities for rolling a 4 would be if I roll a 1 and a 3, or a 3 and a 1, or I could roll a 2 and a 2. And so I only have 3 of those cases, and so for mine it would be 3 out of 36, which if I put that on here, that's going to be, let's see, rounded to 2, I think it's just 0.08. And so we can check that one on here. 0.08 is looking good. So hopefully that makes sense. We just end up with more outcomes, ways that we can get the sum of 6 or a sum of 4 than you expect, because some of those look the same, but they're not really the same. All right, let's look at question 6 was the next one. And so on this one we have we're tossing a coin 3 times and counting up numbers of heads and calculating some different probabilities from these. So let's look at this and make up our diagram for this one, because I think this really helps. And so we start off our first toss, we can get either a heads or we can get a tails, right? So here's our first toss. And then our second toss, from there, if I rolled a head on my first one, I could then also have rolled a heads the second time, or I could roll a tails, right? And, or if I'd rolled a tails on the first one, I could have then rolled a heads, or then rolled a tails here. Okay, so these are my combinations, and then the third toss goes on that same way from there. If I rolled a heads and then another heads, I could then roll a third heads, or maybe this time it was a tails. And same thing's going to happen for each of these, right? Could go into a heads or a tails for each of those from there. And so the combinations we have, we kind of have to follow these paths along. If I started with a heads on my first toss, I could have then gotten another heads and maybe gotten a third heads. Or I could have had a heads and a heads, and then I could have gotten a tails on that one. Or maybe I rolled a heads the first time and then I rolled a tails, and then I could have rolled another heads, or I could roll a heads, a tails, and then another tails. And so we're, if you're kind of seeing, we're kind of following all of these branches out here on our tree to get these combinations. So I've got 4 so far where I rolled the heads the first time. And that covers all of those where my first toss was a heads. Now I'm getting into, okay, my first toss was tails. And so if I had a tails the first time, I could then get a heads and another heads. Or I could go tails and then get heads and then maybe another tails. Or I could get a tails and then a tails and then a heads. And last of all, I have this path down here where I get a tails and a tails and a tails. Right there. And so I end up having 8 outcomes from this. Okay, so 8 possibilities of combinations that I could get of heads and tails with these 3 tosses. And so then it's asking for different probabilities, and I don't know if you have the same numbers that I have, but my first one was the probability of getting 0 heads. And so as I look at these combinations, there's only one of these that has 0 heads. And so that would be a probability of 1 out of 8. And I think this one said you can give it as a fraction or a number between 0 and 1. I found the decimal and it accepted that one as being correct there. For our next one, if I'm looking at getting just 1 heads, we have one right here where that's 1 heads, and one right here where we have 1 and 1 right here. I think there's just those 3 for that one, where I have just 1 head, right? Either I got it first toss, the second toss, or the third toss. And so that would be a probability of 3 out of 8. And so the rest would work from there. And so once you can get all 8 of these possibilities, those probabilities aren't too bad to calculate. Just have to make sure you get all of the possibilities when you figure these out. And so what are these possible combinations, or what we're looking for as our outcomes on that. So hopefully that makes sense with that one. The last question you had was question 8. And so again, I think I have different numbers. You mentioned using 19. My numbers are 15 and 7. So it says Leanne flipped the coin 15 times and got 7 heads. And we're looking at her probabilities. And it said you had trouble with the margin of error on this end. So let's look at that with my numbers, because I'm not sure what your other numbers were, but it should be the same, at least similar idea. And so mine says she tossed the coin 15 times and got 7 heads from those tosses. And so calculating the probability, just, 7 out of 15, right? And then we're going to find that margin of error for this. And so margin of error is going to be 1 over square root of n is what it says in your textbook. And so n in this case is going to be this total number of tosses that she made. And so I want to do 1 over square root of 15. And so you mentioned doing the square root of 19 in your email. And so I wondered maybe you just forgot that 1. So make sure you take 1 and divide it by that square root. And so in my calculator, if I do this, I'm going to do that 1 divided by, and I'm going to put some parentheses in here so that I can do the square root of 15 and make sure that's going to be in my denominator. And so sometimes those parentheses are helpful to make sure, okay, it's doing the square root part before it does the division. That makes sense. And I recommend, if you can, type it all in at once. That's going to be our best bet. And so mine ends up being 0.258. I think it wanted 3 decimals on this one. Yeah, and so rounding to there was our margin of error. And so that's looking okay on this one. If you do the square root part first, some things to watch out for, just rounding on that. And so if I were to do 15 and find the square root, and then I need to do 1 divided by this big long decimal, and it says in there, round to 3 decimal places, but I don't want to do that yet because I can end up with rounding errors if I round too soon. And so I would want to keep at least 5 or 6 of these decimal places. And so 3.8729, whatever, keep a bunch of those decimal places in this when you do the division. And so what that would look like if I do 1 divided by 3.87298. I'm going to keep a few more decimal places than it says to round to so that I can avoid these errors, rounding errors. And so you can see if I round this one to 3 decimal places, I get the same thing I got before. And so that's important. Keep these longer decimals. And the same thing on this confidence interval, right? We're getting this, and this margin of error is part of that confidence interval calculation. But probably instead of using 0.258, I would use 0.258199 or something longer decimal, and then round these to 3 decimal places in the end. And that's going to be more accurate. I won't have those rounding errors on that. All right, I hope that helps with some of these questions you had. Please let me know if you still are having any trouble with any of these or have any more questions, and I'll be happy to answer your questions and try and help you get through this stuff.